Hi guys, hopefully you have Lady in front of you. I'm going to be working through a few problems with you. This will be checked off tomorrow. When you finish this, you can work on your practice midterm packet, and the midterm, of course, is Thursday and Friday, so I'll answer any questions on the midterm review tomorrow in class. All right, so these first two problems, nothing new, but we're going to go through them just to refresh your memory before going on to a little twist that they'll have. So we first want to get cosine by itself, so we're going to subtract 5, divide by -3. So being careful with our signs, that tells us we're looking for the angle where cosine is -1/3, which is non-special. It's not one of our special ratios, so we have to use our calculator. And cosine is going to be negative in the second and third quadrants. Okay. So remember to be in radian mode when doing these problems. So we're going to do cosine inverse of -1/3. Whoops. And remember, that is punching out the answer in the second quadrant, because cosine inverse is defined for the first and second quadrants only. So 1.911 rounded to the nearest thousandths. And remember, this is punching out this arc right here, which is equivalent to this guy. So always to find that second angle with cosine, we're going to take 2 pi minus that value the calculator gave you. It will give you that angle in the third quadrant. So we're going to take 2 pi minus my answer, which will be 4.373. Now remember, on a test, always remember to double check that you are in the correct quadrants. And if I were you on the test, I would just, write these out. Remember, this is 0 radians, 3.14 radians. Half of that would be 1.57 radians. And then if you add those together to get 3/4, the way around would be 4.71 radians, and all the way around is 6.28 radians. So again, just double check that 1.911 is between those two values up here, as well as 4.373. So looks like we did it right. Awesome. Okay, now a sine example. We already have sine by itself, so we're going to simply go to our calculator, and I always like to draw the unit circle, making sure I know where these should lie. So sine being negative will be down in the third and fourth quadrants. So when we punch this in, sine inverse of -0.97, that's giving us that negative value. Remember, sine inverse is defined only in the first and fourth, so that's what it's giving us, that backwards angle here, -1.325. But remember, we don't want that answer because our domain restriction is 0 to 2 pi. So to get that same location 2 pi later, we're just going to add 2 pi to that. I'm not going to write that answer. We want the location 4.958. Okay, that's my answer in the fourth quadrant. Now remember, we still need this value, because to get this other angle in the third quadrant, we're going to be taking pi minus the negative value or plus this arc that was just plugged into my calculator. So I'm going to, let's see, go back, I'll just punch it back in. Sine inverse of -0.97, enter. We're going to take pi minus that value, which is actually adding it because we're going that amount past pi, which will be 4.467. And that's where it's really valuable to double check, because a lot of people will subtract the positive value or add it incorrectly. So making sure that you are where you should be with what you wrote down on your paper, which makes sense. Okay, awesome. So the only twist on the first page is that you're going to be given different domain restrictions, so pay attention to this, because we're not always giving you 0 to 2 pi. So make sure your answers lie within the domain. So I'll just do one of these for you. The front page is pretty straightforward. So minus 1 divided by root 3, so we want cosine theta equals 1 over root 3. We get a positive value, so that means cosine is positive in the first and second. Sorry, the first and fourth. I don't know what I'm doing here. Sorry, guys. First and fourth. And so we'll be getting these two values. But the answers we want are only between pi and 2 pi. So from pi to 2 pi, these are the only answers I want. So actually I'm going to cross off the 1 in the first quadrant, which is what the calculator is going to give you. So do cosine inverse of 1 divided by square root of 3, which in the first quadrant is going to be 0.955. We're not going to write that down, but I'm just writing it for your notes. And remember, to get that second one, we're going to take 2 pi minus that answer. So the one in the fourth quadrant, which is what I want, is 5.328. So only one answer on that one. Okay, so you guys can finish the first page, no big deal, but we do need to look at a few problems on the next page, labeled Your Friend the Calculator. Okay, these are preview problems to what we're going on to next week. We're going to be looking at word problems containing cosine curves. And so you'll have some ugly equation, and you'll have to either substitute a value for x and find y, or you'll have to substitute in y and solve for x. So it's just knowing how to punch these in correctly to your calculator, and I'll show you some common errors that you want to avoid. Okay, so the first one seems pretty easy. We're going to plug in 7.8 for x. Uh-oh. What is going on? All right, so punching this in, I'm just going to say 25 times cosine of 2 pi divided by 5. Now, notice most calculators put that parenthesis in right away when you punch cosine. Make sure your calculator does. So I wish this was written with brackets around the whole thing. This whole thing belongs to the cosine. So what you need to worry about is adding an extra parenthesis right here to get the correct answer. And I'll show you what that looks like. So once I put in 2 pi divided by 5, we need to put parentheses, my x value, which is 7.8, minus 15, close parentheses, that's just this guy right here. I need to tell it I'm done with the argument for cosine, so I need to add an extra parenthesis here. That's the biggest mistake on the test. And then add 40 and hit enter. Rounding to the nearest thousandth, we have 16.756. Okay. Now, just to show you, if you did forget that extra parenthesis, I'm going to delete that extra parenthesis, which is the common mistake. It doesn't give you the same answer, so just to prove that to you. So that's the only caution on part A. Now, part B takes a little bit more work, you guys. Some of you will be able to do a lot in your head, but I'm just going to write out the steps the first time so you kind of see, and a lot of you will just use your calculator without showing a lot of the steps. So, let me erase this here. What we're going to be doing is plugging in 60 for y. Oops. Sorry, we're going to plug in 60 for y, so I'll write 60 there. And again, you don't have to show this work, but I'm just writing the steps out so that you guys can see what I'm doing in the calculator for the first time. Okay, so we want to first subtract 40. Okay, so we're going to get 20 here equals 25 cosine of 2 pi over 5 times x minus 15. And then essentially it's working from left to right here. We want to divide by 25 here. So we're going to get 20 divided by 25. Which gives me 0.8. I'll go ahead and write that. And then that's equal to cosine of 2 pi over 5 times x minus 15. Okay, when you get to this, we subtracted and we divided. To undo the cosine, we want to do cosine inverse. Okay, so cosine inverse of this value is going to give me this long decimal. So I'm going to keep that in my calculator, but I'm going to write it down just to show my steps. 0.6435 and so on should equal, that cancels this guy out, we're going to get 2 pi over 5 times x minus 15. Now, again, working left to right, you can do this different ways. I like to multiply by 5 and then divide by 2 pi, but this is the part where people mess up. So if I multiply by 5, I'm going to get this decimal. You want to make sure you don't divide by 2 pi like this, because what have we forgotten? I hope you guys are all realizing this is not telling the calculator to divide by 2 pi, it's telling it to divide by 2 and then multiply by pi. So you can add parentheses, or, and hit enter, or to be safe, I think what Mr. Reader suggests is you can divide them individually. So you can divide by 2 and then divide by pi, or use your parentheses, but make sure you put parentheses if you're going to do that. Okay, so now I've got this decimal 0.512 dot 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 equals x minus 15 because I got rid of this guy. And then finally just add 15. So x will be 15.512. Okay. And like I said, it looks like a lot of work, but you guys will kind of see how to solve for these. We're just subtracting first, then you divide, take the cosine inverse, multiply by 5, divide by 2, divide by pi, then add 15. You're just reversing it from left to right. Okay, we can try one more of those real quickly. I'm just going to do, actually pause the video and try number 12. Hopefully the sub will pause this. And then I will put up the answers to 12A and B and see if you guys got those right. All right, guys, here's the answers to number 12. And if you forgot that extra parenthesis on the first one, you would get 1.448. So notice that's the one without the extra parenthesis. Hopefully you guys all got that. And then the second one, 6.510. So I'll just show you real quickly how you got that. So negative 11 equals negative 30 cosine of 2 pi over 4.6 times x minus 6 plus 12. So I'm going to do it without showing the work this time. Negative 11 minus 12. So I subtracted that over. I'm going to divide by negative 30. Okay, so that's equal to this guy right here. So I'm going to take, so I got rid of these guys. Now I'm going to take the cosine inverse of my answer. Just 0.697 dot dot dot, that equals 2 pi over 4.6 times x minus 6. Multiply by 4.6, divide by 2, divide by pi. So times 4.6, divide by 2, divide by pi. That got rid of this guy, then we add 6. You should get 6.510. So I hope that wasn't too fast. If you guys need to watch this again, I have posted it on my pre-calculus page. So ask the sub where you can watch that again, or hopefully this wasn't too bad. Finish this for tomorrow, and I'll see you guys tomorrow. Good luck.